All right, welcome to lesson 9.3. Inside of this lesson, we're going to be looking at the Pythagorean theorem again to decide if a triangle is a right triangle or not. So we have a pretty straightforward theorem here, and it says if the Pythagorean theorem works for our triangle, then it is a right triangle. So you just need to test to see if the two legs squared added together equal the hypotenuse squared. And if that is true, then we know we have a right angle between the two legs. So here we have a triangle, 50 centimeters, 75 centimeters, and 100 centimeters for the longest. So I notice 100 centimeters is my longest number there, or biggest number there. So that would put my right angle here. So then my two legs would be 50 and 75. So what I want to do is apply the Pythagorean theorem. So I'll go ahead and take 50 squared plus 75 squared, and I'm going to see if it equals 100 squared. So you could put a little question mark above this equal sign to test to see if it is true. So 50 squared is 2,500, 75 squared is 5,625, and 100 squared is 10,000. So what we're going to do is add these two together. We get 8,125, and this would need to equal 10,000 to make this a true right triangle, but it doesn't obviously equal. The two numbers are not the same. So therefore, we're just say this is not a right triangle. The Pythagorean theorem is not true. Later on in Algebra 2, we will study how to actually find that angle, but not right now. Next, we look at this triangle. We have 5, 12, and 13. So 13 is the biggest number, so that would be the hypotenuse. 5 and 12 would be the legs, so 5 squared and 12 squared. Take us to 25 and 144. Adding these together, we get 169 equals 169. And yes, those are the same numbers. So there we go. It is a right triangle. So the right angle would be here. And we're done with the problem. So pretty straightforward. We're just testing the Pythagorean theorem. It says uses in the real world too. Sometimes carpenters do this when they are framing a house. And what they will do is they will measure the distances on their sides, so the length and width as noticed in this picture, and then they'll measure the diagonal across, and that will tell them if these two walls are perpendicular to each other, because obviously to build a house you definitely need it to be perpendicular, the walls to be perpendicular. You don't want to create a house that's oblong, and so they would measure this diagonal and they need the Pythagorean theorem to hold true, and if it doesn't hold true they need to refix it until it does hold true. So they'd have to check that angle. So here they have 11 and 18, and the middle diagonal is 21.25. So they'll plug in their numbers, 11 and 18, and 21.25. So squaring 11 takes us to 121, squaring 18 takes us to 324, and squaring 21.25 takes us to 451.56. And adding our numbers together on the left side, we're going to get 445, which takes us really close to 451.56, but the numbers aren't quite the same. And so the numbers do need to be exactly the same to get a proper 90-degree angle there. And these would be off by far enough where they would need to go back and recheck that angle between the two walls. So they're close, but not quite. And here we have a few more. So like, for example, will a triangle with side lengths 7.5, 10, and 12.5 be a right triangle? So you just identify the biggest side, 12.5, that's the hypotenuse. And then you square the two smaller sides and see if they add to equal that big side squared. So 7.5 squared, 10 squared. So we square those numbers, add them together, and this one does work. We get the same number equals the same number, so that is a right triangle. Here, 5, 6, and square root of 11. If we take a look at the square root of 11, we can go ahead and take the square root 11, and we get 3.316. So I know that's going to be the lowest number. So square root of 11 squared is 11, 5 squared is 5, and 6 squared is 36. And then we end up with 36 equals 36. So that one does work. That concludes lesson 9.3.